Good morning all of you, and today we are going to discuss about the second type of transfer of heat, that is convection. And when we are discussing this convection, first we can explain one activity. In the beginning of that conduction, I told you that means the distribution of notebooks in class. Okay, so in this picture you can see that for distributing the notebook, the teacher tell the students to make a line, and in that line one by one the teacher is giving the book. Okay, so that we can consider in the case of convection. Okay, this convection mainly we learn that the liquid and gases are bad conductors of heat, right? Okay, so these liquids and gases, when we are considering time, they heated in another process or another transfer of heat, that is considered as convection. Okay, so when we consider about this convection, we need to discuss its definition. Okay, so convection is a process of transfer of heat in a liquid or a gas by the actual movement of molecules of the liquid or gas. So in that picture you already seen that when the teacher is tell the students to line up, they all change their position or they all change their seat. Okay, so that only here they means in the case of conduction, the transfer of heat in a solid by without the actual movement of molecules. But in this case, convection, the transfer of heat in a liquid or gases by the actual movement of molecules. Okay, so now we can discuss the activity for the better understanding of the concept. So for doing, we have to show that the liquid transfer heat by conduction. We need to show that the liquid transfer the heat by convection. So for doing this activity, we required a rounded bottom flask and potassium permanganate in chemical and Bunsen burner, then an iron stand, water, tripod stand, these are the things, and a spatula. These are the things we required for doing this activity. So how can we do this activity? Okay, so we have to take this flask, rounded flask, as you can see in the picture. In that flask we have to add 3/4 of water into it. You can see the water also. Then we have to add a small piece of potassium permanganate. We need to add it gently with the help of spatula. Okay, then we have to means this when we consider about this potassium permanganate, it's a crystal. Okay, and its color is purple color, and we have to after that what we need to do, means that potassium permanganate crystals, means when we heat it, so that time we can see that the potassium permanganate crystal dissolves slowly and form the purple colored solution. Okay, so this heat here you can see with the help of Bunsen burner, we are heating the potassium permanganate and water containing that rounded flask. Okay, so that time the heat the water using this Bunsen burner. Okay, so then we have to heat this flask with the help of an Bunsen burner. So that time when we are heating time, we can observe that a purple colored solution rises from the bottom of flask up to the surface of the water. Okay, so then moves towards near the walls of the flask. And how does it happens? Okay, when we heat the water from the bottom of the flask, so that means near the flame, it will heat it, then it expand, becomes lighter. It expand and becomes lighter. So what happens, this hot water will rises upward and carries the heat to the upper surface. Okay, here in this pink color you can see that the hot water rises up. Okay, and from the top there will be cold water. Okay, cold water is present at the surface. Okay, this will move down by the side of the flask to take the flask of hot, and rising the walls towards the sources of heat. So after some time this water also get heated and rises upward. Then cold water from the above surface again come down. So this process repeated. So we can say that heat is transferred from hot water at the bottom of the flask to the cold water at the top by the actual movement of water molecules. Okay, so this cyclic movement of water is considered as what? Convection. Okay, so we can conclude that heat is transferred in liquid by convection. When we discuss about conduction, we learn that conduction is only present in solids. Okay, here in liquid and gases, convection can occur. Okay, so in liquid and gases, when we are considering time, this heat is transferred by convection. Okay, why? Because their molecules are free to move. In solid, their molecules are not free to move. Okay, so here there is a molecules free to move. So molecules of solids are closely packed, so that movement is not possible in solid. So that's why convection does not take place in solid. In the definition of convection, we discussed that it is the transfer of heat in a liquid or gases by actual movement of molecules. Okay, in this activity also you can see that cold water from the surface come down and hot water rises up. So there will be an upward and downward movement of water molecules. Okay, so there is an actual movement of molecules in liquid or gases, so it makes convection. Then another activity, now we can discuss how does convection takes place in gases or in air. So for doing this activity, we have to take a rectangular box with a glass, and this front side there will be two holes. We have to place two holes on its top. Okay, and we place two glass tubes in these holes. In that two holes we have to place two glass tubes through that hole. Okay, and it helps to form chimneys. Okay, what is the use of chimneys in kitchen and all? We can see it emit the smoke. Okay, so when we consider about, we have to make them by placing the glass tubes. It creates the chimneys, and we put small lighted candles below one of these chimney. Okay, here in this picture you can see that lighted candle is there in one of the chimney, means a chimney B, right? Okay, and that chimney, when we are considering time, how to do, and all the, here you can see that a paper, okay, burning paper near the mouth of the chimney. Okay, and that chimney is A. Okay, you can see that smoke is enters the box through chimney A. Okay, and comes out from the chimney B. Okay, that smokes, when we place a burning paper, that time when there is a burning paper, smokes will be there. So that smokes we allow to fall through this chimney A. Then you can see that this smoke comes out through chimney B, right? So this is because air above the candle get heated, and that air becomes lighter and it will rises up. Okay, this create a low pressure region, and to balance this pressure, air from the outside is sucked inside the box through the chimney A. So when we are doing this, air sweeps out smoke and paper along with it, and this setup we can consider as convectional current. Okay, so in this case, convectional current or convection current in air, when we are considering time, we took a rectangular box. Okay, in the top of this rectangular box we have to place what? Two holes, and through that two holes there will be two glass tubes are there. These glass tubes will be like a chimney. We have two glass tubes, glass tube A and B. Okay, so then this burning paper we have to place just above the chimney A, so that time the smokes will enter into the rectangular box through this chimney A. Okay, so that smokes emits by chimney B. That is because we placed an candle, burning candle here. So when the smoke comes near to the burning candle, it rises up because it becomes lighter and it rises up. So that's all about the activities. Now we can discuss the practical application of convectional current. So first one is ventilation. Okay, when we consider our rooms and all, in your room when you are like in your home, when you are looking, different rooms will be there. Okay, so in each and every rooms, ventilation or ventilators are provided and exhaust fan near the top of the side walls. Okay, so this air that is mainly because of when we breathe. Okay, so that time what happens, we produce a warmer air. Okay, so this warmer air is lighter. So what will happens, it is lighter than the air present around it. So this air, which means that this lighter air, that means the breathe out air, it moves up in the room and escape through the ventilation. Okay, then as a result fresh air enter to the room. Then what will happens, and means the fresh air can enter to the room through the windows and air holes and doors. Okay, so it makes the room fresh. So there is an upward and downward movement of air, right? So this upward and downward movement of air keeps the room fresh. And second one is chimneys. Okay, the chimneys normally it is fitted in factories, and that is mainly to remove undesirable smokes and fumes from the factories and all. Okay, so when we consider them, they are actually hot, so they will rise us up. Therefore means whenever this air or liquid anything is hot, so that time it will become lighter and it will rise us up. Okay, then third one is installation of room heaters. Okay, it is provided to place the room heaters at the ground level of the ground level for effective heating. We are placing the room heaters in ground level. Why? Means in the case of room heaters, the warm air near the heater actually needs to rise us up. We already discussed that warm air is lighter, so it needs to rise us up, and cool air from the other areas rushes into the fill space to fill the hot air space. Okay, so this cool air is again heated up by the heater, then setting up and conventional current. So this upward and downward movement of air creates an convectional current or convection current. So this all the air inside the room becomes warm. Okay, so that's all about these three applications of conventional current. And next one is conventional current in nature, convection current in nature. Okay, it maybe you already learned in SS and or sea breeze and land breeze, that we discussed on the basis of sea breeze and land breeze. Mostly in coastal areas and all, these breezes generally blow from the sea to the land. Okay, if the breeze, or when we consider if the breeze flow or blow from the sea to land is considered as sea breeze, and it actually occurs during the daytime. And the breeze, when we consider the breeze blows from land to sea, it is considered as land breeze. Mostly these happening at night, during night. So now we can explain detailedly about the sea breeze and land breeze. When we consider the sea breeze, the land will absorb the heat faster than the sea. Mostly the land will absorb the heat faster than the sea. Okay, so what will happen during daytime, our land heats up more quickly than the sea. Okay, daytime in land that heat will be more than the sea. Okay, as a result, air present above the land surface become heated and expand, and it will rise us up. Okay, so this cooler air which is present in the sea surface, it come towards the land and keep the land cooler, or to take, and it takes the place of warmer air over the land. Okay, so there is a movement of air from the breeze, sea to land, that is considered as sea breeze. Okay, and this sea breeze or the cool air from the sea is blowing towards the land, that is considered as sea breeze, and it mostly occurs in daytime. Okay. And now we can discuss the land breeze. And land breeze is mainly occurs in night time. Why? Because in land loses its heat faster than the sea. Okay, land loses its heat fastly than the sea. So at night time land cool fastly than the sea water. So the air present above the sea being warmer, so what happens? It will rises up. So as a result, the cool air which is present in the land blows towards the sea to take the place of that rise. Means I told you, that warmer air present above the sea level rises up. That space will occupied by the cool air from the land. So this cool air from the land blowing toward the sea is called land breeze. Okay, so that's all about land breeze. Now we concluded the portion convection. Convection means that it is the transfer of heat by the actual movement of molecules. Okay, and last transfer of heat process is considered as radiation. Now we can discuss the radiation. Okay, so when we discuss the radiation, that time also we can come back to that activity. Means I told you that the distribution of notebook, the teacher may throw the notebook directly to the students without disturbing the others. Okay, so that you just keep in mind. Directly the teacher can give the corrected notebook. Okay, so that way the heat energy is transferred without the need of any medium. Okay, earlier cases I told you that some mediums are there, solids, liquid and all, and in this case it does not require any medium and they are radiant heat. So radiation is a process of transfer of heat from hot object to the cold object without any medium. Okay, so we can say that radiation does not require any medium for its propagation. And how can we can explain it? When we sit in front of an electric heater, we feel warm, right? Why? Because that heat travels from the heater to our body. Okay, so the air is between you and the heater is a bad conductor of heat. When we are sitting near the heater, so that time we feel warm. Okay, so that is because of the heat energy or heat is transferred from the electric heater to our body. Okay, then this air and in between this heater and in our body air is present, as we know that air is a bad conductor of heat. So we can say that heat cannot be transferred by conduction. Okay, it will not, that we proved, because air is a bad conductor, heat cannot be transferred by conduction, and heat at the same time it will not transferred by convection also, because the hot air surrounding the heater will become light and rises upward and not towards our body. Okay, so in this activity when we are discussing time, we can say that their radiation occurs. Okay, when we sit in front of an heater, so that time we feel warm. That the reason of that feeling of warmness is not because of conduction or convection, because we know that in between means if I am sitting in front of the electric heater, so that time I feel warm. In between me and the electric heater only that air is present. Air is a bad conductor of heat, so conduction will not occur. And in convection case also, the hot or warm air actually it will rises up, it will not come towards us. Okay, so convection also will not come, will not consider in this case. So when the heater, means after that if we switch off the heater, then immediately we feel cold. Okay, so it shows that the air around our body remain cold. Okay, so there must be a third process of transfer of heat in which the medium is not heated, so that is considered as radiation. Okay, so these radiation examples are when we receive the heat from the sun, it is actually through radiation. Okay, and when we consider most of the space between the sun and the earth are actually vacuum. Vacuum means that the absence of medium. The heat from the sun reaches to us traveling through the vacuum. Okay, so that's all about radiation, and in the case of radiation, heat energy is transferred without the need of medium. Okay, and absorption of radiant energy we can discuss. Light, when we consider the light is a form of radiant energy, is it right? Because the light we are getting from the sun. Okay, in daytime we are depending the light from the sun, so it travels a great speed in all the direction, and from then it does not need a material medium. So the light, okay, when we consider the light falls on an object, then what will happen? It may partly absorbed or reflected. Okay, so we can say that the radiant heat falls on an object. That time also it will partly absorbed and the remaining part will be reflect back. Okay, so just listen here. When we consider the light ray, when it strikes an object, it will reflect back. This means that object will absorb the light rays and it will reflect. The same way radiant energy also absorbed by the object and reflected also. So the temperature of object increases due to the absorbed part of radiant energy, and this absorbing power or reflecting power of the substances depends upon the nature of surface and color of the object. So nature of surface and color of the object which depends the absorbing and reflection of radiant energy, that also we can discuss with the help of an activity. For doing this activity we require two cans and two laboratory thermometers and wooden blocks. Okay, then how to do this activity? We have to take an identical cans, two identical cans, and one of the can we have to paint white paint, or we have to paint it white color, and the other one is black. Okay, then we have to pour equal amount of water in both the cans. Both the cans we have to pour equal amount of water. Then we have to fix a laboratory thermometer by using a rubber cone. Okay, then we have to note the temperature, means we have to place both the cans over a wooden blocks in a bright sunshine. Okay, means we have to place both the cans in front of sunlight, means sunshine, and that heat radiation of sun will fall equally on both the cans. So we have to make sure that the heat or light from the sun falls equally on the both cans. Okay, then after an hour, when we read the temperature of water in both the cans, then again place the tin cans in the shade of some time and note the then again we have to note the reading of thermometer. So that time we can say that the observation, when we are observing it, we can find out that initial temperature means at the beginning means we have to place water in both. So that water temperature is in the beginning, or initial temperature of water in both the cans will be exactly equal. But when both the cans are placed in bright sunshine, water in the black can is at higher temperature than the white can. It is mainly because of the color. Okay, black color can absorb more heat energy. Okay, and so we can say that the black color tin can has absorbed more heat of sun than the white color can. Okay, so when the cans are placed in shade, when the cans we placed in the shade after the sunshine, after sometimes after 2 hours and all, when we place in shade, the water in the black tin can is at lower temperature than in white tin can. That is because of the black colored tin has emitted heat faster than the white colored tin. Okay, so as a conclusion we can say that the color which depends the reflection or absorption of the light energy. Okay, and at the same time one more thing you have to keep in mind, that when we consider shiny and smooth surface, they are better reflectors. Okay, and when we consider dull or rough surface are better absorbers. Okay, now we can discuss the application of radiation. First one is, in summer season mostly everyone are telling to wear white or light colored clothes, because this white and light colored clothes absorb very less heat energy, that already we discussed it. And secondly, the houses in the hot places mainly painted in white or light color. That is also because of this is done mainly to house to absorb less heat from the sun and keep the house warm in summer. Not warm, cool in summer. Then thirdly, the bottom of cooking utensils are painted black, right? So while the sides are sparkling bright, this is because of the utensils need to absorb more amount of heat. Okay, so that's why we are painted it black. Then for next one is, when we consider the containers of solar cookers are painted black to absorb more heat from the sun. And at last we can say that electric room heaters have curved polished metal reflector behind the heating element. The polished surface reflects back the heat radiation falling on it. So thus keeps the person sitting in front of it warm. Okay, so that's all about our class. In today's class we were discussed about convection and radiation. Conversion occurs in liquid and gases by the actual movement of molecules. Okay, and radiation is actually the heat energy transferred from the hot object to the cold object without the need of any medium. There does not require solids, liquid or gaseous state. Okay, so that's all about it. Its applications are very important and activity is also very important. So you just try to read the textbook, and next class we can discuss the exercise part. Okay, thank you.